Hello, my name is Chris Slackford, National Training Manager for HP Products. Thank you for your interest in learning about central vacuum installation. For our presentation today, we'll break the process into three categories: planning, roughing in, and finishing. We will begin with the planning section. One of the first things to do during the planning process is to make sure that you have all the correct tools to do the job. A tubing cutter is way more useful and faster than a saw during the installation process. The other specialty item is the tool used for drilling holes to run the tubing through. My personal preference is the Milwaukee D-handle drill pictured. I also strongly recommend using a 2 9/16 self-feed style bit for the hole. Before proceeding with planning, we will want to know what type of system will be installed: a conventional plug the hose in the valve system or a retractable hose system. We will start with a conventional system. As a rule of thumb, one standard conventional inlet valve covers approximately 600 square feet. This formula is helpful when you are doing a quick estimate for a system. Now is also the time to determine any installed accessories. The vroom is handy in kitchens, bathrooms, or anywhere there is a cabinet. Spot works like a vroom, but is installed in a wall. Vac pans are installed in toe kicks or baseboards and use a broom. It is also helpful to know what type of cleaning kit will be used with the installation: air-driven or electrified. The type of cleaning kit used will play a part in the type of inlet valves specified. This chart details parts required for a single central vacuum inlet. You can multiply at times the number of inlet valves required for the job to determine a bill of materials. Obviously, you would not need one can of PVC adhesive for each valve. Generally, one can will cover enough for dozens of inlet valves. Universal valves can be used with electrified power heads provided a hose with a pigtail cord is utilized. This chart details the parts required for the different accessories. Again, one can of PVC adhesive will cover dozens of accessory installations. Here are two options to allow a direct connect electrified valve. These valves will utilize a direct connect hose where both a low voltage and 120 volt is incorporated into one connection. We will break the planning process down into three steps: locating the inlet valves, determining the power unit location, and determining the routing of the tubing path. This slide shows valve placements in a typical house. Notice the overlap of coverage between the valves. It is helpful to plan your inlet valve locations by measuring with a 25-foot piece of string or a tape measure to ensure full coverage. Typical locations for inlet valves will be on inside walls, hallways, near doors or archways, the bottom of stairs, or near the large garage door. Always avoid areas behind doors or furniture or in the middle of an open wall. The idea here is to provide maximum coverage with minimum number of inlet valves. Now would also be the time to determine the vroom location. Typical locations for vrooms are anywhere there's a cabinet and quick clean is required. Vroom 24 needs 21 3/4 inches minimum depth. Anything smaller than that will require the vroom 18. The garage is also a great location to install a vroom. Depending on construction, the garage ceiling bracket can be installed above the drywall at rough-in or below the drywall at finish on the ceiling. Now would be the time to determine where you're going to locate the power unit. Generally speaking, a power unit is located in the basement or the garage. What's most important is to make sure that it is on a dedicated circuit. If you are exhausting the power unit, it is important to keep the exhaust as short as possible, less than 30 feet including all of the fittings. It's also important not to vent into anything that's concealed space or in an area like patios or in entryways. Thoroughly planning the tubing run will save you both time and effort, as well as give you the most efficient and high-performing system. Now it's time to rough in. It's always best to be the last contractor in, right before drywall and insulation. There are two different rough-ins that you can perform: a full rough-in, where you basically run all of the tubing that's required for the job, or a stub-in, which is basically just stubbing tubing into a basement. Another helpful hint is when you're gluing the components together to remember to apply the PVC glue to the tubing side only. Never apply glue to the inside of the fitting. Depending on the type or style of construction, tubing can be installed going up into the attic or ceiling cavity or going down into the basement or crawl space. Please keep in mind, tubing runs in attics require special consideration. They should be kept low and under insulation, or in some cases separately insulated. Now would be the time to install your universal valve mounting plates. Before installing, it's helpful to check for obstructions by drilling a small pilot hole into the floor or into the ceiling and checking for other obstructions. Once you verify the location, it's now time to drill a 2 9/16 diameter hole in the center of the sole plate or top plate near the stud. Always avoid areas near electrical wiring. It's helpful to install a short 90-degree elbow behind each inlet valve. This prevents large objects from entering and clogging the system. Please note, only use short 90 elbows behind inlet valves, vrooms, and vac pans, never anywhere else in the system, especially the exhaust. Once you've attached the mounting plate, now would be the time to glue the tubing stub to your short 90, rough in for your wire, install your nail guards, and install your plaster guards. Typical cabinet locations for the vroom are usually sink bases. Stub the tubing out approximately 6 inches to the left or right of the P-trap height and attach low voltage wire to the stub. For the vroom garage rough-in, stub the pipe near the desired area and secure to the corresponding joist. For vac pan rough-ins where you have an open basement, I like to cut a hole in the floor under the corresponding cabinet, and then I cover it and make note to keep open for later connection. For finished basements or slab construction, I'll stub the pipe and wire behind the corresponding cabinet location. This chart is a useful reference for determining efficient tubing runs or for exhaust length calculations. As discussed earlier in the required tools section, use a tubing cutter for the fastest and most accurate cut. Then deburr the tubing as required. After cutting, I like to dry fit the tubing and fittings together to ensure that there's a correct fit. And then I glue them one section at a time, remembering to glue only the outside of the tubing and not the inside of the fitting. Branch lines will then connect into the trunk line with TY fittings. Always run branch lines out of the side or the top of the trunk line, never out of the bottom or anywhere below horizontal. This will create dirt pockets, as shown in the illustration. It is also very important to make sure that the TY is installed in the proper direction, as shown in the illustration. Oversimplifying, you're going to run branch lines to the main trunk line from each inlet drop, and you're going to begin from the furthest inlet and work towards the power unit. Now would be the time to run your low voltage wire. At the connections, be sure to leave slack in the wires. Strained wire connections may pull apart. Be sure to secure the wires along the tubing path and all the connection points with zip ties or clips. Keep in mind, wiring can be completed in a valve-to-valve method, spliced at tubing junctions, or with home runs to the unit, so long as you remember the following. Low voltage wiring has no polarity. Wiring is always connected in parallel. Now it's time to finish the system. The first thing to do is to wire the inlet valves. You'll remove the plaster guards, split the low voltage wire, strip the insulation back, and attach the wires to the screwed contacts on the back of the valve. When installing the valve, be sure not to over-tighten or under-tighten the screws, as this will hamper the operation of the valve door. Once installed, the inlet valve should be level and cover all sides of the hole. Otherwise, please use a trim plate. When installing the vroom, locate the cardboard template inside the cabinet, place the mounting bracket in the template and secure with 5 screws, remove the template, install the side panels so edges tuck under 5 tabs, attach the tool brackets, and snap the vroom into the mounting bracket. Using a combination of short 90s, long 90s, and 45-degree fittings, tie the vroom into the central vacuum system. Dry fit the assembly and use an escutcheon plate with the wire in place. Glue the assembly and attach to the trunk line. Do not glue the vacuum line to the vroom fitting on the unit. It must be a friction fit for easy removal. Using wire nuts, attach the low voltage wires from the vroom to the low voltage wires from the trunk line. Push the excess wire through the escutcheon plate. Upon completion, test the operation of the vroom. Finishing the vac pan with an open basement involves 6 steps. First, cut the opening for the vac pan. Connect the low voltage wires. Install the vac pan snug to the floor. Then, in the basement, attach the short 90 to the top of the vac pan without using glue. Connect a sweep 90 to that short 90. Then connect the pipe and wire to the branch line in the basement. To install a vac pan with finished basements or a slab home, cut a larger opening for the vac pan to accommodate a short 90. Then attach the installation kit hose to pipe under the cabinet and install the vac pan snug to the floor using trim plate to cover larger opening. When hanging the power unit, follow the specific instructions for your unit on installation height. Connect the intake line to the power unit and secure with a clamp. Then connect the low voltage line to the power unit. If you're exhausting the unit outside, please keep in mind to keep the exhaust as short as possible, never exceeding 30 feet, including all fittings. Note that max air requires metal exhaust with sleeve. Now we will discuss the installation for hide-a-hose. Hose is a retractable central vac hose system where each inlet has a hose stored inside its own vacuum tubing. Longer hoses can be used, so therefore fewer inlets can be installed. This will save time and effort. A 50-foot hose can cover up to 2,200 square feet. Planning the installation for a hose system will require discussing power unit selection, inlet valve location, and tubing layout. This chart details parts required for a single hose vacuum inlet. You can multiply it times the number of inlet valves required for the job to determine a bill of materials. Like the earlier chart, you would not need 1 can of PVC adhesive for each valve. Generally, 1 can will cover enough for dozens of inlet valves. Inconspicuous areas or hallways that don't have high visibility are the best location for hose inlets. The maximum wall thickness without modification is 3/4 of an inch. You will need to know the length of hose that's going to be used for a particular valve to determine the location. You will also need to know whether you're running the tubing in an up orientation or a down orientation. And keep in mind, you must store the hose on the same plane. In the up orientation, where the pipe goes up into a floor or attic, the top of the valve will be installed even with the top of the light switch. Do not install the valve low in the up orientation. In the down orientation, where the pipe goes down into a floor or the crawl space, the bottom of the valve will be even with the electrical outlet. Do not install the valve high in the down orientation. Level and attach the rough-in plate to the stud and attach the fitting to the rough-in plate. You must be more diligent about deburring the tubing in a hose installation. Any burrs will snag the hose sock and impede hose retraction. The pipe fitting is attached to the top of the mounting bracket. Use the retainer band to hold the fitting in place. Have enough pipe length to hold the hose before joining the pipe run. Use only hose special sweep 90s, 45s, and 22.5s in the tubing that stores the hose. Avoid using back-to-back 90s. And also try not to use more than 4 90s per valve. The more 90s you use, the more force needed to pull the hose from the wall. Connect the pipe to the fitting and run the tubing into attic, basement, crawl space, or ceiling cavity as construction allows. Avoid installing pipe in extreme heat or cold without considering insulation. These examples show tube routing in an up orientation, a down orientation, and both up and down in a 4-valve layout. Please note that all of the tubing is stored with the hose on the same plane. Before installing the mud cover, record the corresponding hose length inside the mud cover for future reference. Now you're ready to trim. Remove the mud cover, connect the low voltage wiring, and apply silicone grease to the O-ring. Insert the valve into the frame and level the valve. It will adjust to wall thicknesses up to 3/4 of an inch. Secure the valve with screws by aligning the 4 valve and frame holes. Do not over-tighten or under-tighten the screws. Attach the door and insert the hose. It is helpful to cycle the hose in and out of the valve 4 or 5 times to help relax the hose. Verify the operation of the magnetic reed switch and be sure that the door opens and closes properly. A hose handle is available in a radio frequency or a non-radio frequency. Always run low voltage wire regardless of the style used. A remote handle will give you on-off capability at the end of the hose. There is an automatic shutoff after 30 minutes, and you can program up to 5 handles on 1 receiver. This completes our presentation today. Thank you again for your interest in central vacuum systems.